Hello everyone, I hope you're all doing well. I'm going to solve one more problem on moments about a point using the scalar approach, that is, using the right hand rule to obtain the direction of the moments. Okay, so here is a problem. And I have a previous problem on moments about a point using the scalar approach. Please take a look at that too. All right, so here I have an L-shaped body. It's an L-shaped beam, let's say. Okay, I'm going to draw that very quickly. So here is that situation, and on this body there are a couple of forces, as you'd have guessed, acting on this one. And sometimes straight lines are my downfall. All right, so this beam, I'm going to say, is maybe fixed at this particular point here. Okay, so I'm going to call that point as the point O. Usually that's what I do. And then I have a couple of forces that are acting. These forces are shown to you in the following manner. This force here is a force of magnitude F1, which is 1000 newtons. F1 is 1 kilonewtons, which is 1000 newtons. Okay, and you're told that the angle made by this force with the horizontal is 30 degrees. So nice, good looking force. Okay, then I have another force which is acting at a different point on this body. Okay, so I'm going to call that force as the force here, which you're going to be seeing. This force is F2. Okay, we are not given the magnitude of this force, surprisingly, but I'm given a slope triangle, which I'm going to draw here. Okay, so the slope triangle is your typical 3, 4, 5 triangle. As I said, in statics, whenever you see a triangle, whether it looks like a right angle or not, at least in the course that I teach, it is treated as a right angle triangle. Okay, so this force is acting at the point A. So this is the point of application of that force, point A. Okay, this force is acting at what I call as the point B. Then some distances are given to us. Okay, so here are the distances. Distance from point O to point A is given to me as 2 meters. Okay, and I'm going to draw them as dotted lines in a minute, as you will know. Okay, so this is 2 meters. Then I'm told that the distance from point A to point B is about a meter. Okay, so starting from here all the way on to there, this distance is about a meter. So obviously my drawing skills have a lot to be leave a lot to be desired, right? Because this is not drawn to scale. Okay, so this is a distance of 1 meter. Okay, so I'm just going to put a disclaimer here before somebody accuses me. Not to scale. Okay, so that's something I want to let you know. All right, so this is not to scale, and what I'm also going to see is there is a distance from the point O to the point B, which is given horizontally. Okay, so that's important. That distance is given to me here. Okay, and I'm going to say that that distance is a height of 1 meter as well. All right, so now I'm going to mark all these as dotted lines. You got to give me a minute to do that. Okay, and likewise I have this distance here, and then all these lines as well. There should be a way of maybe selecting all of these at the same time, just like you do in like Word or something like that. Maybe somebody knows the trick to do that. I don't know. I'm still a newbie when it comes to doing all these kinds of things. Alright, so here is a situation that you're given. Now, you're told the following. This is an interesting problem, okay? You're told that the resultant moment due to these forces about the point O is 0. Okay, so given that the net moment about the point O due to the forces F1, which is 1 kilonewton, and F2, which we don't know, is 0. Okay, so which means that obtain the force F2 and specify its direction. Okay, which is important, right? Because we don't know whether the force is acting this way or not. So this is the information that we are told. Okay, what do we need to obtain? We need to obtain the magnitude of the force F2, and we also need to specify its direction, which means that whatever we are given here is a suggestion. Okay, it is approximately acting this way, either in this way or it's acting out. We don't know if that is the right direction. Okay, it could be completely flipped. Okay, specify its direction, meaning is it acting the way it is given or is it flipped? Okay, so I just want to clarify this. So is F2 acting the way it is drawn, acting the way it is drawn, or is it flipped? Okay, that's what we need to find out in this particular problem. Okay, interesting problem. It's different from what we've done in the previous one. So here I'm told that the moment is 0, find the force. In the previous one I was told, okay, here are the forces, find the net moment about the point O. Okay, all right. So what am I going to do? The first thing I typically do in any of these problems is set up an axis. Okay, so I'm going to do that here. So this is going to be my y-axis. Okay, then this distance, I'm going to just mull over that, and then I'm going to say that is the x-axis, which means the axis that is coming out of the page is the z-axis. Okay, this is a planar problem. Okay, so planar problem. Okay, or a two-dimensional problem. Okay, so which tells me that if I have a planar problem, the direction of the moment is either into or out of the page. Okay, that's typically how it works. Okay, so for a planar problem, so something that you want to note. Okay, so note, for a planar problem or a two-dimensional problem, the direction of the moment vector is either into or out of the page in or along the third direction. Okay, along the third direction. All right, so this is typically how it is. Okay, but nice problem in a sense that, I don't know the force. I'm given the moment is 0, so how do I find the force? The first thing I always do in any of these problems is break the force into their components. Okay, so that's what I'm going to be doing. I'm going to take this entire figure. Once again, please notice that the axis was not given to us. Okay, so I drew these axes. I'm going to maybe make a note of this as well. So these, I drew these. They were not given. Which is something you want to keep in mind. Okay, whenever you're given a problem as an engineer, the first thing you got to do, okay, what the hell is this axis for? I want to put it on this problem. So which is the x-axis, y-axis, z-axis? I choose a right-handed system, and then I say, okay, this is the x and this is the y, and that's the z-axis. Okay, this is typically how I do it. All right, so I'm going to bring the problem down here, and then I'm going to start breaking it up into components. Okay, my idea is that the key idea, of course, is okay, maybe let me write that down here. Okay, so the key idea is that the resultant moment about the point O is going to be the moment about the force F1 and moment about the force F2. Okay, and we are told that the net moment about the point O is 0, and I'm saying this is in a k direction because of the fact that, then I'm going to link that to what I had written here. So I had written that here, so this is why it's in the k direction. Since it is 0, it doesn't matter whether it is positive k or negative k, right? Because 0 times something is always 0, but it is still a vector. Okay, so this is a 0 vector. Okay, all right, so that's 0. So that's the key idea I'm going to be using. So my aim now is to take these forces and break them into their components. So it's getting a little crowded here. I'm going to cut this off and then say, okay, this is the force F1. Okay, I know the magnitude of the force F1. F2 I don't know. So here is what I'm going to do. Take the force F1, let me use this color, break it up into its components. Okay, so there is one component which is going to be acting in the horizontal direction. There is going to be one more component of F2 acting in the vertical direction. Okay, this component is going to be F1 times cosine 30. This component is going to be F1 times sine 30, right, as you would have easily guessed. Then I see, okay, this force F2, I'm going to take that and break it into its components. Okay, so point of application, always note the point of application is where the components either meet or start. Okay, so there is one component this way, there is another component acting this way. Okay, and so this is going to be 3/5 F2, which is acting vertically, and this is going to be 4/5 F2. Okay, so these are the components. And then right away I realized that, okay, hey, look at the force F1 cosine 30. Its line of action intersects the point O, so it is not going to cause any moment about the point O. Okay, so that's something I'm going to write down. Okay, so F1 cosine 30 has its line of action intersecting, if you extend it. Okay, so if you take this blue colored thing and then if you extend it, right, its line of action is passing through the point O, so obviously it's going to cause a zero moment or rotation about that point O. So it has its line of action intersecting the point of interest, which is the point O, which means that F1 cosine 30 will not cause a moment about the point O. Okay, so that's a cosine 30 there. Sometimes my writing is as sloppy as, I guess probably the sloppiest thing I know is me, so my writing is as sloppy as me, and straight lines come back to haunt me in my dreams. Okay, so F1 will not cause a moment because its line of action intersects the point of interest. Okay, so that's great news, so I can get rid of this creature here. Okay, I don't want to do that, of course. So which means that I'm going to clean up my act, and then I'm going to redraw this figure without this F1 cosine 30, and maybe get rid of some of the other extra forces as well, so that I can do it a little more cleanly. Okay, so here is the situation I have. Okay, and I'm going to say, okay, this F1 is known to me, so I have taken care of this one, so I'm just going to get rid of that. Okay, then I have also taken care of that one, I'm going to get rid of that. Okay, this creature is of no concern to me, I'm going to get rid of that. This is gone here, that's gone, and I don't know what that is doing here, so I'm going to get rid of all of that. Alright, so this is the cleaned up figure now. Okay, and it looks much better. And what is my next idea? My next idea is, okay, find the net moment about the point O due to each of these forces. Okay, so I start off by looking at the force F1. So the net moment about the point O due to the force F1. So use the right hand rule. Okay, first of all, the magnitude from the point O, draw a line that is parallel to the force F1 sine 30, then join them together by means of a nice smooth perpendicular line. So this distance is 2 meters, not drawn to scale, as you see, which means this is going to be F1 sine 30 times 2. But what is the direction? Use the right hand rule, fingers of your right hand aligned with the force, turn the fingers, your palm facing the point of interest. This is going to be in the positive k direction. Okay, then I look at the other two. Okay, moment about O due to the force F2. There are two components, so please be careful. Okay, each of them has a perpendicular distance with respect to the point O. Okay, so here is what I'm going to do. For the 3/5 F2 force, I'm going to find the perpendicular distance by doing the following. From the point O, I draw a line that is parallel to that force. Okay, then I join them together by a nice smooth straight line. So this is going to be the perpendicular distance, which is going to be 2 plus 1, 3 meters. Okay, then right hand rule once again, First of all, magnitude is 3/5 f2 times a distance of 3 meters. If I use the right hand rule, fingers of my right hand aligned with the 3/5 f2, my palm faces the point O, curl my fingers, this is going to give me something in the K direction. Okay, that's important to know. And then I have one more. Okay, I have one more, this 4/5 f2. How do I find its perpendicular distance? Here is what I do. Okay, from the point O, so let me take a different color now. From the point O, okay, let me I got to do a few things here. So let me draw a line starting from the point O that is parallel to this particular force. Okay, you can see that that line is parallel to the line of the action of the force F2, which I'm going to extend here. Okay, so that is the line of action of the force F2, which I'm extending. And then you see that this distance here that I'm drawing in the purple color, which is given to me as 1 meter, is going to be the perpendicular distance. So which means that this is now going to be plus 4/5 f2 times that perpendicular distance of 1 meter. What is the sense of the moment or the direction of the moment? Right hand rule once again. Be careful. Bring your fingers along the force f2. Your palm should be facing the point O, so it will feel as if you are underneath this L-shaped bar, the horizontal portion of the L-shaped bar. Curl your fingers, direction is coming out of the page. Okay, so that's going to be in the K direction. So we have all these done, which means that if I say resultant moment about O is MO due to F1, MO due to F2, okay, but we know that MOR is 0K, okay, so which means all I have to do is just substitute. So 0K is equal to F1, which was given to me as 1000. So let me write this as F1 sine 30 times 2K. This is the moment due to F1. Moment due to F2, there are two components, okay, both of them contributing. And if you want it for the moment due to the force F1, you can say that this was F1 cosine 30 times 0 in the K direction. Okay, the second component was not contributing in any way. And this is going to be 3/5 F2 times 3 in the K plus 4/5 F2 times 1 in the K direction. Okay, and then all I have to do is isolate this force F2, and we also know that the force F1 is 1000 newtons. Okay, substitute. So this is going to give me 0K is equal to, all of these are in the K direction, so I can just add them up. So this is going to be 1000 times sine 30 times 2, 3/5 times F2 times 3, 4/5 times F2 times 1 in the K direction, which means that, I can just equate the magnitudes of these two vectors. And so this tells me that, okay, 3/5 times F2 times 3, 4/5 times F2 times 1 is equal to minus 1000 sine 30 times 2. I just brought the minus 1000 sine 30 to the other side. Okay, if I solve for F2, I end up getting 192 newtons. So this is very, very nice. You see, the magnitude of this force is 192 newtons. Okay, so which means magnitude of F2 is 192 newtons, and the direction of F2 is negative, which means that it's flipped. You look at the question, go back to the question, and then they were asking you, is the direction drawn the way it is drawn, or is it flipped? Which means that, if I get a negative value, then the direction is actually flipped. Okay, so this negative value tells me that, okay, negative sign tells me that the direction of F2 is flipped. Okay, and that is because of this negative sign here. So this is that negative sign that is warning me of this happening. All right, so fantastic problem. I hope you're able to go through it at your own pace. If you have any questions, I'll be happy to answer or email. Okay, all right, take care of yourselves. Bye-bye.